Space is a three-dimensional continuum containing positions and directions. In classical physics, physical space is often conceived in three linear dimensions. Modern physicists usually consider it, with time, to be part of a boundless four-dimensional continuum known as space-time. The concept of space is considered to be of fundamental importance to an understanding of the physical universe. However, disagreement continues between philosophers over whether it is itself an entity, a relationship between entities, or part of a conceptual framework. In the 19th and 20th centuries, mathematicians began to examine geometries that are non-Euclidean, in which space is conceived as curved, rather than flat, as in the Euclidean space. According to Albert Einstein's theory of general relativity, space around gravitational fields deviates from Euclidean space. Experimental tests of general relativity have confirmed that non-Euclidean geometries provide a better model for the shape of space. Space is one of the few fundamental quantities in physics, meaning that it cannot be defined via other quantities because nothing more fundamental is known at the present. On the other hand, it can be related to other fundamental quantities. Thus, similar to other fundamental quantities, like time and mass, space can be explored via measurement and experiment. Today, our three-dimensional space is viewed as embedded in a four-dimensional space-time, called Minkowski space, see special relativity. The idea behind space-time is that time is hyperbolic orthogonal to each of the three spatial dimensions. Geographical space is often considered as land, and can have a relation to ownership usage, in which space is seen as property or territory. While some cultures assert the rights of the individual in terms of ownership, other cultures will identify with a communal approach to land ownership, while still other cultures such as Australian Aboriginals, rather than asserting ownership rights to land, invert the relationship and consider that they are in fact owned by the land. Spatial planning is a method of regulating the use of space at land level, with decisions made at regional, national, and international levels. Space can also impact on human and cultural behavior, being an important factor in architecture, where it will impact on the design of buildings and structures, and on farming. Ownership of space is not restricted to land. Ownership of airspace and of waters is decided internationally. Other forms of ownership have been recently asserted to other spaces, for example to the radio bands of the electromagnetic spectrum or to cyberspace. Public space is a term used to define areas of land as collectively owned by the community, and managed in their name by delegated bodies. Such spaces are open to all, while private property is the land culturally owned by an individual or company, for their own use and pleasure. Abstract space is a term used in geography to refer to a hypothetical space characterized by complete homogeneity. When modeling activity or behavior, it is a conceptual tool used to limit extraneous variables such as terrain. We often refer to our expanding universe with one simple word, space. But where does space begin and, more importantly, what is it? Space is an almost perfect vacuum, nearly void of matter and with extremely low pressure. In space, sound doesn't carry because there aren't molecules close enough together to transmit sound between them. Not quite empty, bits of gas, dust, and other matter floats around emptier areas of the universe, while more crowded regions can host planets, stars, and galaxies. From our earthbound perspective, outer space is most often thought to begin about 62 miles, 100 kilometers, above sea level at what is known as the Kármán Line. This is an imaginary boundary at an altitude where there is no appreciable air to breathe or scatter light. Passing this altitude, blue starts to give way to black because oxygen molecules are not in enough abundance to make the sky blue. No one knows exactly how big space is. It's difficult to determine because of what we can see in our detectors. We measure long distances in space in light years, representing the distance it takes for light to travel in a year, roughly 5.8 trillion miles, 9.3 trillion kilometers. From the light that is visible in our telescopes, we have charted galaxies reaching almost as far back as the Big Bang, which is thought to have started our universe about 13.8 billion years ago. This means we can see into space at a distance of almost 13.8 billion light-years. But the universe continues to expand, making measuring space even more challenging. Additionally, astronomers are not totally sure if our universe is the only one that exists. This means that space could be a whole lot bigger than we even think. Space is the vast, three-dimensional extent containing all matter and energy, essentially the boundless region beyond Earth's atmosphere filled with stars, galaxies, and planets, but also vast stretches of near vacuum, described in physics as part of a four-dimensional space-time continuum. It's characterized by extreme cold, low pressure, and the absence of sound, yet it's the fabric where cosmic events unfold, defined by gravity, distance, and movement. Key aspects of space. The universe, it's the vast emptiness between celestial bodies, containing everything from planets and stars to dark matter and energy, which make up most of the universe. A physical continuum, in physics, it's a dimension, or combined with time into space-time, where objects have position and direction, a sort of cosmic grid. A near vacuum, space isn't perfectly empty, it contains gas, dust, radiation, and particles, but it's so sparse that sound can't travel, and gravity behaves differently. Expansion, space itself is expanding, a process that began with the Big Bang and is currently accelerating, linked to dark energy. Defined by boundaries, for practical purposes, we often consider outer space to begin at the Kármán Line, about 100 kilometers above Earth sea level, where the atmosphere becomes too thin to support flight. Other meanings, space can also mean a gap between words, an available area, like parking space, or even time, example in the space of an hour. In essence, space is both the physical stage for the cosmos and a concept describing distance, emptiness, and the fabric of reality itself, defined by the relationships and movements of everything within it. Scientists have discovered a lot about space, how it works and the things in it, but there are still loads of mysteries left to solve. Space is the vast expanse of the universe where energy and matter, stuff that takes up room and has mass, exist. So, it's not a totally empty void, but did you know that less than 5% of the whole universe is normal, visible matter? That includes all the solids, liquids, gases, and other tiny particles that make up the things we can see and interact with, such as stars and planets. While we can't see or detect them yet, we think that dark matter and dark energy opens in a new window are a huge part of the universe and how it works. Space is full of radiation. Some of it is left over from the beginning of the universe. Cosmic microwave background, CMB, radiation tells us that our universe is 13.8 billion years old and started with the Big Bang. Since the Big Bang, space has been expanding, going from a single point to the size it is now. In fact, it's still expanding and at an accelerating rate. We don't know why expansion is getting faster, but scientists think it has something to do with dark energy. For official records, we often say that outer space begins at 100 kilometers above Earth sea level. We call this the Kármán Line. But there actually isn't an exact point where the sky ends and space begins. Instead, the higher you go, the thinner Earth's atmosphere gets until it becomes space. The outermost layer is called the exosphere and ends at least 10,000 kilometers from Earth. Material spewing from the Sun provides a protective bubble around our solar system called the heliosphere. This material's effects end at a boundary called the heliopause. Beyond this is interstellar space, the space between stars. A nebula is a cloud of dust and gas in space. Nebulae, meaning more than one nebula, are often where new stars form as the dust and gas gets pulled together by gravity. Dying stars can also create nebulae when they throw out their contents in the final stages of their life. Some nebulae emit their own light while others reflect the light of nearby stars. Dark nebulae obscure light, creating dark patches in the sky. Stars are giant balls of superheated gas. Atoms are squeezed together at their center creating elements and energy that's released as light and heat. Baby stars, called protostars, form when a nebula clumps together, collapses under its own gravity and starts to generate heat. When protostars get hot and dense enough to cause nuclear fusion, converting hydrogen into helium, we call them main sequence stars. This phase can last billions of years. Eventually stars run out of hydrogen for fuel and their core collapses under gravity. As the core is squeezed, it gets hotter and the pressure increases, making the star expand. Small stars, such as our Sun, expand from a dwarf into a red giant. In about 5 billion years the Sun will engulf the planets closest to it, possibly including Earth. 5 billion years later, it'll shrink, becoming a white dwarf that'll cool down over billions of years. Giant stars go out with an explosion called a supernova. As their core collapses, it causes massive shock waves. These make the outer parts of the star blow off. What's left is a dense core known as a neutron star. If the star was really enormous, it may turn into black hole after exploding. When stars go supernova, the elements they made get swept out into space. Nearly every element we know of was made in stars. Different combinations of elements creates gases, minerals, water, and other ingredients for life. That means you're made from stardust. Black holes affect physics in ways we don't experience on Earth. Black holes have extremely strong gravitational fields. Anything, matter, energy, and even light, that gets too close can't escape. This point is called the event horizon. At the center of a black hole is the singularity. This is where our laws of physics break down, meaning we can't predict what happens there. They don't emit light or other radiation, so we can't look for black holes in the same way we search the sky for stars or planets. But we can still find them. We can detect the gravitational waves black holes make or look for light-emitting accretion disks of dust and gas around them. We find stellar mass black holes throughout galaxies. These have masses a few times greater than our Sun. Supermassive black holes have masses hundreds of thousands to millions of times greater than our Sun and are found at the center of galaxies. Stars have strong gravity. Everything near to one gets pulled towards it. This stops objects, such as planets, asteroids, and comets, from flying off into space. These objects travel really fast, so fast that they counteract the gravity pulling them towards the star. This means they orbit around the star rather than spiraling towards it. Most objects that travel around stars have slightly elliptical orbits, meaning they follow an oval-shaped path. We call a star with planets orbiting it a planetary system. So, our solar system is a planetary system. We call it the solar system because solar refers specifically to our Sun. It formed when a dusty disk called the solar nebula collapsed under its own gravity about 4.6 billion years ago. Ours is one of thousands of planetary systems that have been discovered in our galaxy, the Milky Way. Galaxies are made of stars, the objects orbiting them, dust and gas, all pulled together by gravity. Galaxies come in different shapes but most, including the Milky Way, are spiral galaxies. These are flat, rotating disks with arms that spiral out from the center. Most large galaxies have a supermassive black hole at their center. The Milky Way's is called Sagittarius A** and is more than 25,000 light-years away from Earth. Planets. For an object to be a planet, it must orbit a star, be big enough that gravity has forced it into a spherical shape, have used its gravity to clear other similarly sized objects from its path. There are 8 planets in our solar system. We group them into 3 types: terrestrial planets, gas giants, and ice giants. Mercury, Venus, Earth, and Mars are terrestrial planets. They have a solid surface and are mostly made of metals or silicate minerals, where the rocks are composed of silicon, oxygen, and other elements. Jupiter and Saturn are gas giants. These don't have a solid surface and are mostly made of swirling gases, such as helium and hydrogen. Uranus and Neptune are ice giants. They're made from hydrogen and helium too but are orbiting really far away from the Sun, so their gases are mostly frozen. There are also a few dwarf planets in our solar system, including Pluto and Ceres. These are similar to planets but don't meet all three of the key criteria to be counted as one. Exoplanets are planets outside our solar system. These can be similar types to planets in our solar system or entirely different types. For example, we've found super-Earths, which are more massive than Earth but lighter than our ice giants and hot Jupiters, such as HD 189,733b, where it may rain glass. Earth and its nearest neighbors orbit the Sun, which is a star, but there are also rogue planets that wander freely through interstellar space. Moons orbit planets and some asteroids. While gravity has forced our moon into a spherical shape, other moons are more irregular. Our moon formed 4.5 billion years ago. It's relatively benign now, but the dark patches on its surface, called lunar maria, opens in a new window, were once seas of molten lava that have solidified into a rock called basalt. It also has its own atmosphere and some water trapped in its rocks. Other planets' moons are more volatile. For example, Io, which orbits Jupiter, has more than 400 active volcanoes across its surface. Not all planets have moons. Mercury and Venus are moonless. Other planets have many more moons than Earth. Saturn has an incredible 274 moons, and we keep discovering new ones. Asteroids are rocky or metallic objects that orbit our Sun. They're left over from when the solar system formed. Asteroids range in size from a few meters to hundreds of kilometers in diameter. Some are material that's loosely scooped together, while others may be more solid with metallic cores. Around 37,000 asteroids orbit the Sun at a similar distance to Earth or closer. We call these near-Earth asteroids. The majority, however, are found further away, in the asteroid belt between Mars and Jupiter. Sometimes bits of asteroids break off. We give these space rocks different names depending on whether they're still in space or have entered Earth's atmosphere. Comets are like big, dirty snowballs. They're balls of dust, rock, and ice that come from the Kuiper belt beyond Neptune or the Oort cloud at the edge of our solar system. Some have extreme oval-shaped orbits. Short-period comets complete a full orbit of our Sun in less than 200 years, whereas long-period comets take more than 200 years. When their orbits bring them close to the Sun, the warmth makes them release gases, which sometimes form a visible tail behind them. Space, a boundless, three-dimensional extent in which objects and events occur and have relative position and direction. Thank you for watching this video.